In this warm-up here, we have a graph and we're asked to find the wavelength for one cycle. So when we're talking about one cycle, let's just review what we've learned about sine and cosine graphs. So when it comes to a sine graph, this is where you have it starting at the origin at 0 and ending it at 2 pi, but in between it goes up, then back down, and back up. And the highest it goes is +1 and the lowest it goes is -1. So when we're talking about one full cycle, it goes from 0 to 2 pi for a normal sine graph. Whereas for a cosine graph here, cosine graph starts at +1 when it's at x equals 0. And then at 2 pi, it ends at +1. So halfway point is where it dips down all the way to -1. So it kind of looks like this, where it goes up, then down, and then back up, and there we go. So it kind of looks like a U-shape graph. So looking at the shape here, what I notice is it's at 0. It's starting at 0. And then it goes up to 2 and then back down to -2. So I can kind of tell like the amplitude is 2 up and 2 down. So looking at that there, I can also see that the wavelength is, let's grab a thicker highlighter. That is one cycle of sine. So I can tell that this graph is a sine graph and this represents one sine cycle. So it goes from 0 to pi to complete one cycle, and then it repeats again. So you can see that's another length of pi. So the wavelength here is about pi. And this one is a sine graph. Now for this one here, it definitely looks like a cosine graph. But if I look at the x-axis, I start to notice something here. So this one has an amplitude of 5. It goes from 0 to 5. Up and 0 to 5 down. And what I notice is it starts at 0 and this one full cycle, or to make this U shape, takes about 4 pi of a length. So this whole wavelength takes about 4 pi. So this helps us get into our next topic, which is understanding period and phase shift. So let's start with understanding period. So period is the wavelength of a full cycle. So you guys just saw that when we were looking at the cycle, we wanted to know how long the cycle was or how long it took. And so that's considered the wavelength, which also is another way of saying period. So period is the wavelength of one full cycle. Now, when we're talking about phase shift, that is specifically talking about the horizontal shift. So we've already talked about vertical shift, but we have not talked about the horizontal shift. Now in trig language, you often hear it called as the phase shift. Now let's put this all together and talk about all the different shifts that we have learned so far and what we're going to be practicing on today. So let's grab a different pen color here. So we have amplitude. And we've learned that amplitude is always positive. So we've learned this formula where the A is always in an absolute value to help us remember that it will always come out positive. And next is this B value here. This B is going to help us find our period, but it's not the period value. So the B is used in a formula for the period, which is P equals 2 pi over B. So in order to figure out what your period is, you have to plug in the B value, and the B value is always next to the X. So let me just reiterate here. Typically, when it comes to the period, it takes about 2 pi. The wavelength for an original sine or cosine graph is 2 pi. So if I were to use my period formula, I would have 2 pi over 1, because technically there's a 1 in front of this x, so I'd put this over 1, and my period is 2 pi. So that makes sense because we can see that the length here is 2 pi. So this period will change depending on what number is in front of x, and it could either shrink the period or make the wavelength shorter or make the wavelength longer, depending on what is the number in front of x. And x is usually inside of the sine function, so you can see it's inside the trig function in parentheses. Okay, the next thing I want to mention is the phase shift, or this minus h. So that is your phase shift or your horizontal shift, some people call it. So whenever this sign here is a negative, that means you're going to be shifting right. If it's positive, you're going to be shifting left. This might sound very familiar because it's like most horizontal shifts work like that. But I do want to mention is that if there's a number in front of x, you're going to have to divide that out before you can determine your phase shift. And we'll practice that so we can understand what that means a little bit clearer. And then this plus k, we've talked about it before. That is the vertical shift. And so any number that's outside of the trig, usually to the right of it or being added or subtracted on, is your vertical shift. So positive means up, negative means down. And that is all of the shift for a trig function. And we're today going to specifically practice finding period and finding phase shift. So let's start in this video with practicing finding periods that have been shifted. So I'm going to shrink this down just a little bit. So here we have a trig function, and we need to state the amplitude, period, midline, and phase shift. Now, first off, this here looks like a cosine graph, and cosine, you remember, generally looks like that U-shaped type of graph for cosine. So I just drew a little quick sketch here. And for our graph here, there is a 2x inside. That's a little bit different, but let's fill out these questions here. So the amplitude, this cosine here has a 1 technically in front of it, so our amplitude is going to be 1. Remember, the amplitude is always in front of the trig. As our midline here, I don't see a vertical shift, so I can tell my midline is at y equals 0. And it looks like I don't have a phase shift because there's not a minus or a plus some number inside of the parentheses. Notice how like a phase shift usually has a minus or a plus number next to the x that's inside, but there isn't one. So this one does not have a phase shift. So I'm going to say 0 because there's no phase shift, or you can write no shift. And then let's go calculate our period. So the period uses a formula, P equals 2 pi over B. And our B here is 2. So it's the number in front of x. So if I plug in 2 and I divide, the 2's cancel, so I'm just left with pi. So my period here is pi. Okay, so if I were to graph this here, I would draw a graph. And I would need to think about how I want to scale this. So one of the things I already know is that the midline is at y equals 0. So I know I should be on the x-axis here at y equals 0 when I'm drawing. So this is my midline. I know the highest point that I'm going to go from the midline is 1 unit up and 1 unit down, looking at my amplitude. So far relatively simple. So the 1 is the highest I can go, -1's the lowest I can go. And there's no phase shift, so I'm starting at x equals 0. But the thing that I realize is that my period has been shrunk. That means one wavelength, instead of it being 0 to typically 2 pi to complete a full cycle, it has now been shrunk to 1 pi. So when I think about the drawing the wavelength, one cycle needs to be completed in 1 pi instead of 2 pi. So to do this, let's first understand we're drawing a cosine graph. So this is going to be a U-shaped graph. So if I were to draw it, it might help if I were to half this. If I were to half it, that would be pi over 2. That's where cosine typically dips down to -1. So cosine generally starts at +1 and ends at +1. And then if we were to half it even more, this would be pi over 4. And this part would be, let's see, between pi over 2 and pi, this would be 3 pi over 4. And so cosine usually swings down first, like this, and then goes back down further, and then comes back up and goes back up to make that U shape. So what I'm doing, maybe I should draw a bigger picture of this. So typically a cosine graph looks like from 0 to 2 pi, and you would half it to make pi, half that and make it pi over 2, and then this part would be 3 pi over 2, -1, and so you would start at 1, go down, continue to go down, back up, until you get back to 1. So that's what a typical cosine graph looks like. But for us, we have to squeeze it between 0 and pi instead of 0 to 2 pi. So you can kind of see what I was going with. I was trying to label the amplitude so I knew how far up I should go and how far down I should go. And then I just kept halving pi until I can get all the coordinate points. So for this problem, you just need to draw one full cycle of the trig function. You can continue to add more cycles. Like if I were to extend this out to 2 pi, I can draw one more cycle because pi to 2 pi is one full wavelength. So I could draw one more cycle to cover that, but I don't have to. All right, let's practice this with the next trig function. So this one's going to be a sine graph here. So in this graph here, or trig function, we have b as 1/2, or the number in front of x is 1/2. So if I were to find my period, I would have 2 pi over b, which is 2 pi over 1/2. So I have a fraction in the denominator, but we've dealt with this before. We're just going to take the denominator and flip it, so that'd be 2 over 1 if I were to flip 1/2. And so if I multiply straight across, I would get 2 times 2, which is 4, but bring the pi over. So 2 pi times 2 is 4 pi over 1, which is just 4 pi. So I have my period. My amplitude, the number in front of sine is just a 1, so I just have an amplitude of 1. I don't have a vertical shift. As you can see, there's no plus k or like a plus a number or minus a number out here. So there, the midline is still going to be at 0, so y equals 0. Now there's also no phase shift here because next to the x, there's inside the parentheses, there's not like a minus a number or a plus a number, so there's no phase shift. So I'll put 0 for the phase shift, or you can just put no phase shift. So from here, I can now start drawing my graph. But let's first understand a typical sine graph. So sine, highest number is 1 and -1, and it goes from 0 to 2 pi to make one full cycle. Starts at the origin, goes up, comes back to the middle around pi, and then goes back down and comes back up to 0. So this is what a typical sine graph looks like. And if we were to draw ours, if I were to draw a coordinate, I know that my midline is at y equals 0, so I can kind of put that on my graph. The highest point I should have is 1, and the lowest point is -1 because my amplitude is 1. Now, I know sine starts at 0, and there's no phase shift, so I'm not moving this starting place. But my period ends at 4 pi. That means to complete one full cycle here where you go up, down, and back to the to y equals 0, this S-shaped curve takes from 0 to 4 pi now. So not from 0 to 2 pi. I have to go all the way out to 4 pi to complete my cycle. So if I were to half this, halfway between 0 and 4 pi is 2 pi. So if I were to start here, to get to the maximum point, which is from 0 to 2 pi, it's the middle point here. Notice from 0 to pi, it is at the maximum point. Well, the halfway point here would be pi. So at pi, it would actually reach 1, and then it would come back down to 2 pi. And so between 2 pi and 4 pi would be 3 pi, and it would go down to -1, where it's its minimum, kind of like from pi to 2 pi, it goes down to -1, and then it would swing back up to 4 pi. And so you can see this one is really wide. The stretch of the wavelength, or the period here, is from 0 to 4 pi. And so that's why our period here is 4 pi, because that's how long the wavelength of one full cycle is. All right, let's try out one more here. So this one's a little bit strange. We have a -4/5 in front of the sine, so that's my amplitude. Remember, we want to write the amplitude positive, so that's going to be +4/5, even though there's a negative. But because there's a negative, maybe as a quick reminder, whenever we have a negative sign, this is going to flip. So this is a sine graph. Sine typically goes up and then down. So if it flips, it's going to go the other way, where it goes down first and then back up. So that's for negative sine of x, that's the difference, that it has the minimum first and then the maximum. Now for the midline, again, there's nothing out here that shifts it vertically. So the midline's still at y equals 0. And again, there's no phase shift because there's nothing inside the parentheses that has a minus or a plus after the x. The period here, we're going to have to plug it into our formula. So our b here is pi over 3. So I'm going to plug in pi over 3. And again, it's a fraction, so I have to flip it. So 2 pi times 3 over pi. So notice how the pi's cancel. That's kind of nice. So 2 times 3 is just 6. So my period here is going to be, looks like 6/1, which is just 6. So I have a period 6 instead of having pi's in it this time, but that's okay. It actually makes it a little bit easier. So I'm going to draw my coordinate system, and I'm starting at 0 because I have no phase shift here. And my highest point is going to be at 4/5. So that's not bigger than +1. So let me make some little dash marks. So that'd be 1/5, 2/5, 3/5, 4/5, 5/5. Again, I'll do that in the opposite direction. So that'd be 1, 2, 3, 4 to kind of show the fifths. And the whole wavelength for one cycle is 6 units. So it needs to go 6 units out. In fact, I might just draw the dashes in between. So half that is 3, and then I'll just put the dashes in between. So that'd be 0, 1, 2, 3, 4, 5, 6. There we go. So we're now up to scale here. So here's our midline, and this is a sine graph, but it's flipped. So we're going to start at 0, but then we have to go down and then back up. So I know halfway for sine is where it hits 0. So in between 0 and 3 would be 1.5 is where it hits 4/5, because the amplitude needs to go down 4/5, which would be down here. So between 0 and 3 would be 1.5, which is right here on the x-axis. And so I would go from 0 down to the minimum, down to the x-axis, and then between 3 and 6 is 4/5, which would be right here, and that's where it would hit the maximum point, which in this case would be 4/5, which is right about there. See if I can match it up. So I'm going to connect the dots. There we go. So we can see that to make one full cycle, it takes about 6 units, so that's our period. Okay, and that is the last set of problems for example 1. So that is it for this video.